Salam sejahtera, salam melaku madu jaya, rakyat bahagia mengambil dunia, salam Jabatan Pendidikan Negeri Melaka, pendidikan berkualiti, insan terdidik, negara sejahtera, #PPD Melaka Tengah, jenama kerajaan nombor 1. Yang berusaha Cikgu Tew Mei Yin dari SMJK Notre Dame Convent, penceramah kita pada malam ini, beliau adalah seorang guru mata pelajaran fizik yang berpengalaman. Saya kenalkan diri saya juga ya. Saya Cikgu Tew Mei Yin dari SMJK Notre Dame Convent, Melaka. Saya adalah moderator pada siri ke-8 pada malam yang indah ini. Saya perkenalkan juga orang penting di belakang tabir kita pada malam ini, iaitu Cikgu Peh Kok Hua dari SMJK Tinggi Cina Melaka sebagai pegawai teknikal yang menyusun atur persembahan live kita pada kali ini. Terima kasih juga saya ucapkan kepada para guru dan pelajar yang sudi meluangkan masa bersama kami dalam program Kasih Gegau Fizik SPM 2021 siri ke-8. Secara ringkasnya, program ini dianjurkan oleh Sektor Pembelajaran Unit SISC plus PPD Melaka Tengah, khasnya untuk membantu anak-anak murid yang bakal berhadapan dengan SPM 2021 pada awal tahun 2022 supaya dapat menguasai cara-cara menjawab soalan kertas fizik dengan lebih tepat dan memenuhi keadaan soalan. Kita amat bertuah kerana pada malam ini kita dapat bersama-sama Cikgu Chia, guru fizik di Melaka ini. Seronok rasa dapat berkolaborasi dengan beliau. Semoga perkongsian beliau dapat membantu anak-anak menghadapi SPM dengan lebih yakin dan cemerlang. Tanpa melengahkan masa, mari kita bersama-sama mendengar tips-tips penting serta teknik menjawab kertas SPM bagi tajuk Elektrik oleh Cikgu Chia. Dipersilakan Cikgu Chia.
Terima kasih Cikgu Tew. Hai semua. Selamat tengah hari bukan, selamat petang. Good evening to all. Salam sejahtera. Okay, today we want to share some tips regarding this electric. Okay, what is electric? Electric basically we will start from a source. There is source. Kita label dia V. Lepas tu kita akan sambung kepada satu load atau beban, sambung dengan litar. Jika litar lengkap, akan ada arus yang mengalir. Betul? Okay, that's it for electric. We got V, we got I, and we got R. You know right? Jika dah, maksud dia habis tajuk hari ini. Electric. Yeah. Just kidding. Okay. We go for the next one. Okay, this is the question 2011 SPM question number 6. Okay, kita perhatikan apa soalan dia. Okay, there is two diagram 1.1 and 1.2. Okay, if we go in detail for these two diagram, the number of bulbs is different. Number of mentor dia different. Dua-dua disambung secara selari. Then what happened to the emitter reading? Check. There is a high value. This is a smaller value. We can check about these two. And then the V is the same one. One cell kering. Polarity sambung pun sama. Okay, because we only got R. This is our R, our I. The current flow, this emitter to measure the reading of electric current. Then we got V here. Okay, check. We go to the next question. Check what's happened to the question. Mentor dalam darjah 1.1, 1.2 disambungkan secara siri ke selari. Okay. Adik-adik semua, what is your answer?
Semua masih high lagi. Belum bagi jawapan. Masih high, hello. Like that.
Okay, this is in parallel or series. Okay, it should be in parallel. Okay, next we go for this is a simple, easy peasy question. Lemon squeezy. Then we go for the B. Okay, based on the diagram 1.1 and 1.2. Okay, bandingkan bilangan mentor. As I go see, Min Jun, thank you for your answer, and Yi Wen, Johan Lee. Okay, there is compare the number of bulb for these two. Which one is greater number and which one is smaller? We use the sign, mathematics sign. Which one siapa besar, siapa kecil? 1.1 is more or 1.2 is more? So should get the answer right. Okay, I share you the answer first. We check. There is 1.1 should be greater number than the 1.2. So this is the exact number. We just use this mathematical symbol. Okay, then we check for number 2. Compare the reading of ammeter. Okay, just now we are enlarged the view of ammeter, right? Then we can check the 1.1 actually is larger reading than 1.2. So it's the same answer like this. Yes, get it?
Yes.
Yes, then we go for the C. What is the question for number 3? State the relationship between the number of bulb and the reading of ammeter. Just how we compare when the bulb get more bulb here connected in parallel, our reading of ammeter will greater. Is considered directly proportional. Then we check for the answer. Is it? Yes, this is directly proportional. Or you can make it more detailed if you scared that maybe mereka tak faham. So you get more detail. Bacaan ammeter bertambah apabila bilangan mentor bertambah. The reading of ammeter increase when the number of bulb increase. This is also a perfect answer to score only 1 marks. Okay, then we go for the next question. C. Okay, give one reason that caused the difference in the ammeter reading in the diagram 1.1 and 1.2. We go and check just now. We got V, we got I, we got R. Our I is different for these two diagrams, but our V is constant, right? So who caused the I reading different? Should be the R. So what is the relationship between this and R? And this and R. So we can say if what happened to the R? To get the higher current, what happened to the effective resistance? Yes, I can see the answer. Lebih tinggi rintangan tinggi. Well done for your answer. So we call it effective resistance atau rintangan berkesan. Dalam lita ini akan menyebabkan bacaan arus yang berbeza. Okay, this is our answer. Okay, the lower effective resistance for this parallel, more bulb is connected in parallel, will cause the higher current flow. Okay, you get the answer? Very good. Min Zun, thank you for your answer. And we check for the next question. D. Make a deduction relating the answer in C and the number of bulb. Just now we said that this is the effective resistance is quite low compared to this, right?
Yes.
And then what happened to the number of bulb? So we can say if the number of bulb is bigger number or more bulb is connected in parallel, the effective resistance will decrease or get lower number, right?
Yes.
Okay, then we check the answer. Jika mentor semakin bertambah, bilangan mentor semakin bertambah, rintangan berkurang, then arus pun meningkat. Yes, I can see this as good boy. Good boy. You're really good. Thank you for your answer. Okay, next we check. Okay, before this, because this is a new topic for KSSM, I want to share it today with all of you. There's called hukum pembahagi voltan or potential divider law and hukum pembahagi arus current divider law. Okay, we check for these two. What is the difference for the connection? Okay, we check here. The R here is connected in Siri. Disambung secara Siri. And these two R is connected to parallel. And we check V, the anonym is potential different, beza keupayaan. Or potential different. We check for this line and this line. All these are V. It means that the same length of here will get the same V. Okay, if we use in lab, we won't susun like this. We will use one wire connect like this, right? Here is connect like this. So means this one and this one is same 2 point. They are sharing the same point. If the 2 points sharing the same point, they have same equal V. So this one, both these also get V. But now the V here divided into 2 parts. Okay, so if you connected 2 voltmeter, they got 2 different reading. It depends on this R. If the R1 and R2 are different value, we can get different V. And V1 and V2, if you total it up, you're all equal to the V source. Okay, this is a basic concept for this circuit. The next one,
they learned already when they were Form 3. Form 2 or
Yeah.
Form 3.
Okay, next, if we go for this one we call, these two R is connected in parallel. And just now our point is, if these 2 points, the V source here, so they are sharing the same point. This one you can take it off, and this one you sum together, actually they are sharing the same point. That's why I say that this is equal to Vs, here also equal to Vs. But when we want to check for the I, we check for the I first. Okay, this is one loop. For Kirchhoff law, for one loop, the same loop, the I here cross all R were same ammeter reading, same current flow. But for here, when you have the parallel connection, this IS, you what? Distribute to 2 parts. Dia berbeza. Okay, it depends on the R. Okay, then we check more detail for the next slide. Okay, we focus on this potential divider law. Okay, we check. Assume this is one pipe. I give you one pipe related to the daily life. If I give you one pipe, the same cost, okay, the cross-sectional area, and I flow the water is flowing. Okay, if water flow, this assume this as our current, arrows or current. And then I go and divide in 2 parts. I cut it off here, and this one I cut here a bit, little bit. Okay, so this is smaller part, this is a bigger part. Then we check for the R. Okay, we want check for the R means R is obstacle. Assume there is obstacle. If I halang here satu, ini halang pun satu, for the current flow. Okay, which one? Because there is many part of here, so the obstacle is more than this part. If you check which R is getting bigger, it's the bigger side, is a longer length. So this R is increased because there are more obstacle here compared to this short length. These are less. And then we go and check V. Okay, V, assume that there is you want to calculate the volume of the water, you store in this and store in this. The V, assume like the volume of water. This one, the V will increase, and this one, the V is lower if compared to this part. Okay, can? And then we check back. Here, the relationship, when R is higher, you will get V is higher when the current flow is the same. So if we compare to here, V equal to IR, okay, this is a relationship between V and IR. And here is constant. So V and R is directly proportional. Okay, then we go back to here. If I calculate to this one, let's say I give you 3 volt, and this is 1 ohm, this is 2 ohm. We can check just now, if R is smaller, the V1 should be get smaller value compared to V2, right? Okay, then we apply this for the potential divider law. We can get, if you want to get the V1, small will get small value. So R1 is small, then bawah ialah tambah total. Sorry, I get this small first. This one R1 plus R2 times your V source or V here. So if I substitute by the value, your V1 will equal to 1 divided by 1 plus 2 times 3. Then you will get 1 volt.
1
3
volt.
and 3, 1 volt, right? Okay, so it proves you. Okay, if I give you another one, for the V2, you will get R2 divided by R1 plus R2 times V.
Times Vs.
And then you will get 2 divided by 1 plus 2 times 3, you will get 2 volt. Okay, it proves you when R is bigger value, you will get bigger V. When the R is smaller value, you will get smaller V. This is a formula for potential divider law, because I got the formula here. I want to show you. Okay, can?
Yes.
I have to remember this. Okay, next we go for the next part.
Like that, very easy to remember using the water pipe. Quite good. Good idea.
Then we go for this one. I also use the pipe. Okay, now the pipe here. I want to get the current flow, but I have two divider, and then one is bigger cross-sectional area, another one smaller. Okay, I let the water flow. Okay, let's say the water can flow to both parts. Water is flowing the same rate. Okay, you check when the water flow here, from here and here. Okay, one is bigger tank, one is smaller. Then we check for the resistance for this part. Let's say, okay, I put one in same resistance. Okay, these two lines. Then you check. If this is wider part, the current flow, and this is a smaller part, and the current flow at the same rate, which one the current will flow faster? Easy to flow, the current flowing.
The one with bigger cross-sectional area.
This one with bigger cross-sectional area will get the R will be getting smaller because it's easy flow. And then so the I here will get easier to flow, will get bigger. And this one, because it's get narrow space, the R, the blocking area is much
higher.
Much higher. So the I is higher, and then your I will susah dah lalu. So the I will get smaller. Then what happened to our V? Just now we said that the V here, they are the same. The V are the same. So we can check here, I and R actually, they are inversely proportional. How to prove with the Ohm's law? V equal to IR, we learn about Ohm's law. And then when this one become constant, we have to separate these two to check their relationship. So V divided by R, right? So when this one get constant, this one and this one will become inversely proportional. Okay, then we check back. If I give you the same idea, this one will get 1 ohm, this one get 2 ohm, but this one is 3 ampere. I want to find the I1. If I use just now the formula we are using for voltage divider law, the smaller answer you put on the top, you will get the smaller value of I. So that's not, it cannot be. So we pinjam opposite. Which one gets bigger value? So we get R2 divided by the total R1 plus R2 times the I source here. Then if I replace by the value 2 divided by 3 times 3, you will get 2 ampere.
2 ampere.
2 ampere, right? So this one will get 2 amp. If you calculate for this one, pinjam sini, 1 tambah 2 darab dengan 3, you will get 1 ampere. So it will prove you the same idea for this one. When R is smaller, your I will get bigger. Okay, then we check. Okay, we check for the, can you see the formula? I hope you can.
Can.
Just now I just write. Okay, these are 2 important tips that we can use it for the coming question. Okay, then we go the next question. I want to prove how to solve it. Okay, for example, for this one first, this is a simple circuit, and then we have to calculate the A, rintangan berkesan, okay, the effective resistance of this circuit. What meaning by total resistance in one circuit or rintangan berkesan? Actually, no matter how many R you have to conclude, simplify in the most simple circuit. What is the total resistance? What is the V? What is the I flow? Okay. When you want to find the resistance, okay, you have to, all these 3, you will conclude into 1. So we are got series and parallel. Next, I go and solve for series and parallel. We got one series tambah series is tambah. Parallel means, like this, right? 9 parallel with 18. This is a mathematical format. It means parallel. And then for parallel form, before this, I think your teacher will teach you like this.
Yes.
Then you solve, right? But myself or my student always forget to upside down the final answer. When it's hard to calculate, you will get, oh, this is my R. Then you get the wrong answer. So today I share you a tips. When I learn in university, we do the calculation like this. Kita darab atas, tambah kat bawah. Then 10 plus, you will get, this one when you calculation, you will get 6. So your answer gets 16.
16.
Okay, 16 ohm for this effective resistance. This called effective resistance. No matter how many R do you have, you want to simplify, become only 1.
Yes.
Okay. Okay, next. This is the answer. And then we go for the B. Bacaan voltmeter. The voltmeter reading for here. Okay, now we can see there is a potential divider. Law can apply here. Okay, why? Okay, check. Just now, this one will become 1/6. The effective resistance was 6, right? So we are using the potential divider law. This is 10 divided by 10 plus 6 times our V source is 12.
12.
Then what can we get? Should get calculate, use a calculator. Anyone get it?
Yeah, got one student get it. 7.5 volt.
Yeah, very good. Yes, it's 7.5 volt. You can get 7.5 volt. Or you think that you don't want to use this, you can use another method. Like simple method like this, we only conclude in 1. Just now we got 1, right? And then this is most simple circuit. This is 16 ohm. And this is 12 volt. The I here, you calculate the I first. The I is from the source. And then when you calculate I equal to V divided by R, then equal to 12 divided by 16, you will get 0.75 amp. But this is not the V yet. Okay, the I flow for this circuit are equal because they are same load. Only here they will pecah dua, right? So here, the ampere flowing here is 0.75. Then darab dengan R, you will get the V. Same answer, 7.5 volt. Okay, you can try for two method. Then we go for the next C. Okay, the ratio reading A1 to the ratio to the reading of A2. Okay, we already get the A1 equal to, just how we calculate, right? A1 equal to 0.575 amp. Okay, then we want to calculate the A2. This A2 here, the count here, O is 0.75. Now it's distributed in 2 parts, it's parallel. We have to applying the, just now we just learned, the current divider law. So we are, can you getting this volume, this value to get the answer? We have to pinjam opposite, right? For the A. So for 5I2, you should get 18 divided by 9 plus 18 times your I source in here is 0.75.
75 ampere.
Okay, then use calculator to calculate. How much can you get?
Student can show the answer, boys and girls. Don't be shy. You can show your answer to all of us here.
The second one is easier. Okay, then we'll calculate. Okay, I done my calculation.
Is it 3:2? Got one student.
Yes,
right,
very good.
3:2.
Okay, then this is I1. It's ratio to 0.5. So use calculator, you will get 3:2. Johan Lee, well done. Thank you very much. Okay. Then this is a question, example question for these two law that is new syllabus for us. Next, okay, we go for another question in section B. Okay, it's SPM question 2012, question 12. We have to score 20 marks here. Okay, we come from the most easy question. What is the meaning of power? What's the meaning of power? Okay, power, you have to memorize what meaning of power. Is the rate of transfer of energy. Because power, I used to memorize the unit. Okay, this is the energy. This is the rate of transfer. It's because it's per time. So we can say that this is the rate of transfer of energy. Kadar pemindahan kuasa. Good boy. Why wait? Okay, next we go for the question B. Okay, check this one. This question, I give you the diagram. I show you, if these two is identical but mentor yang sama, is connected to X to Y of the bulb P. Okay, if I extra one is another identical bulb is connected to this P. Dia nak sambung satu kat sini. Okay, it asks you, what happened to the reading of ammeter and voltmeter? Okay, we check. Okay, these are then, if I added this, okay, we can check what happened to ammeter first. For ammeter, we say that if we want to calculate the ammeter, we have to conclude it into the most simple circuit.
Yes.
Right? Just now, when the more bulb connected in parallel, the R, the resistance will decrease. So hence, this R, when added one bulb connected in parallel, the R will decrease. When the V are equal, what constant? What happened to the I? I equal to V divided by R. When this decrease, the I will increase. Right? Then you can check, this is 1 point. The resistance, the effective resistance will decrease and the ammeter reading will increase. The first, the total resistance in the circuit will decrease and the ammeter reading will increase. And then we check for the voltmeter. What happened to the voltmeter? Okay, the voltmeter here, we only specific for this part.
Yes.
So only measure for this part. Okay, then we check this. Just now we said, if the R, the one more bulb is connected in parallel, the R, the resistance will decrease. And what happened to V and R? V equal to IR. When the current flow are constant, V and R will directly
proportional.
So we can say this called effective resistance for this part. The effective resistance between the X point and Y point will decrease. Hence, the voltmeter reading will also decrease. Get me? Get it? Anyone? Give me some response. Thumb up.
So here we got 4 marks, right, teacher? We got 4 marks right here.
Because we got 4 marks, then we got 4 points. 1, 2, 3, 4
marks.
Okay, good. 2 marks for ammeter and then another 2 marks for voltmeter. It's only asking you to do these 2. Then we go for the next question.
Yes.
Okay, this is C. It asks you to calculate the resistance of one bulb. Okay, only for one bulb. Okay, we know the Ohm's law.
Yes.
Usually, when you want to calculate the resistance, we have to know the V and I. But we got V, no I. How to find the I here? Don't forget, we got power. Okay, still remember the formula for power?
P equal VI.
Or I square R, or V square divided by R.
Over R.
Right? Then we got R, we want to calculate the R, we got V, and we got power. We can use this one. We pick 1, 2, 3. We pick the third one, which is more related. So V square divided by R. Just substitute the V is 6 square divided by R. How much is
easy,
R?
right?
So R, I convert the RP here. So divide by our 18. You will get, calculate, is 2 ohm.
2
Check
ohm.
for the answer. Okay, easy, right?
Yes. Student can try to give the answer, all right? Try to give the answer.
Next, Okay, C2. Calculate the total resistance in the circuit. Total resistance in the circuit, just now we said most simple circuit is find out the total resistance. No matter how many resistance, you go and conclude it out, become the last resistance. Okay, this is a final total resistance, RT. Okay, how to calculate the RT? RT, just now we calculate these 2 ohm, 2 ohm, and 2 ohm.
2 ohm.
Okay, for this one, I go back to the original because they got related 3. Just now my tips only for 2.
For
if
2 only, 2
bahagi
resistor.
bawah only for 2 resistor. For this 3, we do like this. 1/2 plus 1/2, 1/2, and then 3/2. This is what happened to our student. Teacher, over 2 the answer. No, sorry, what happened? So RT should be equal to 3 over 2 over 3. Will equal to? Okay, equal to 0.6667. 1, 2, 3, 4. 4 signifikan 3.
Yeah. Teacher, can left the answer in fraction or not, teacher?
Okay.
Can we left the answer in fraction form?
Okay,
Cannot.
we have to convert
Siti.
Siti Norashika. We have to convert this fraction number into the decimal form. So better in 4 decimal places and give the correct unit. Okay, Siti?
Yeah.
Okay, good boy also. We have to make it in decimal form. Okay, next we go for the next question.
Yes.
This is our answer. And then I show you this one. If you want to use this kind of method, we have to solve 2 first. And then you solve the rest 2, 1 and the last 2. So we'll get the same answer. Then it's for 3. Okay, the total energy dissipated by the bulbs in 3 minutes. And 2 minutes. In 2 minutes. Okay, 2 minutes. And what is the formula for energy? Energy equal to PT. Okay, it's related by mentor, means that more than 1 mentor. They got 3 mentor, then it's not possible to ask you only 2 mentors because it didn't mention the number. So we calculate all 3. 1 15 watts. So how many we have? 1, 2, 3. So the total power is 3 times 18, and then we time the time. Okay, our standard unit in second, right? So we convert the 2 minutes into the seconds. So next we calculate. We will get 648.
Johan Lee. Very good. Well done.
Yeah, it's in Joe. Very good. Good answer. Very good answer. Well done. Okay. Then go for the next. This is another question. Section B will cost you 10 marks. It will give you a diagram with show 4 hairdryer RSTU and ask you to choose to determine which is the most suitable hairdryer. Okay, we check for this. For this 4 hairdryer, and then you have to, for this characteristic, to find out which one is the best. Okay, I make it bigger. Okay, first thing, we want to check the type of heating element. Okay, heating element here, we got nichrome, we got constant, nicron, and constant. For your point of view, which one is better? Okay, normally if hair dryer, we want to convert the electric energy to the heat energy. So we need more resistant. Okay, for the more resistant, nicron and tungsten is better than the constant. So we will pick nicron first. Maybe we pick nicron. Okay, we mark first. And this one, ketebalan daya unsur pemanas is here. Okay, we want the thick one or the thin one. Just now we learn yang besar dengan yang kecil. Mana satu A besar? Remember, we want to convert the electric energy to heat energy. We need higher resistance. So which one will we get?
The thinner.
More resistant? The thinner one, right? So we will choose the thinner one. This one, maybe thin. Or we can say that is a smaller cross-sectional area of the wire. Or the third one, power. Okay, power we got how many? 40, 60, 100, and 80. We cannot choose the number directly. We just use high power or small power, the lower power. So what do you think? You want to get the high power or smaller power?
High power.
Okay, we're still using the same concept. We want to convert to the heat. So we need high power to make it hot in the short time. If not, you are waiting for so long. Rambut sudah kering, dia pun tak panas lagi. Salah tu. Betul. Okay, next we go for the fuse. Okay, this fuse, which one is more suitable is different value. 8, 3, 5, and 10. Next, we should do some calculation. We check. We got volt. Just now we said that this is P, right? P equal to VI. We got V. We want to find the fuse is in current, so we can use this formula. I will equal to P divided by V. So they are same P and V, right? So it's 1000 divided by 240. What can we get? What is the I? The current flow, the optimum current flow in this
1100 is it, teacher?
Sorry, it's 1100. Yes, it's 1100.
Yes.
1100, and then we will get, what is the value? 4.58 ampere. Okay, when we check back, if this is the optimum current flow is 4.58 ampere. If the current over this one, it's a hazard. Means that it's become dangerous because over current. If over current means shock, we are back at the current shock. Itu kan itu mati you. Then if we 8, it probably is higher than this, too far away, so we cannot accept it for this one. If 3, the optimum function for this one when current flow is 4.5, I have not yet achieved, your fuse already burned. So it's not the optimum value for this one. And then the 5 is more close, so maybe this one I can, for this
slightly
one,
higher.
Slightly higher. Then still can. Then this one is more higher. Sudah mati orang oh. Then you pick this, sudah mati orang. So you cannot.
Jadi kena belajar elektrik betul-betul dengan Cikgu Chia, betul?
Supaya tak mati orang Okay, so we check here. Just now we want the nichrome. We will take up this one. And we want the thin should be this one. Then this one, maybe I want the one here. I want this nichrome also here. And the ampere also match. And the power also, consider also high, right? 80.
Yes.
So what can you pick? Ng Min Zun, thank you. So
that was so dangerous. Yeah, okay.
Next
so have to study electric.
Okay, for answer this kind of question, first thing, we draw a table for easy for you and also for the marker.
Yes.
Okay, your teacher also. Then we draw the table first. Then we draw out all the aspect that just test us. First one, we choose the nichrome wire.
Yes.
The second one, we choose a thin wire or the diameter cross-sectional area, the smaller cross-sectional area of wire, or with thin wire also can accept it. And then the third one, we want a high power. And the fuse, we choose 5M, right? 5M fuse.
Yes.
Okay, then you have to write the reason to support your choose. You choose this one. Why? Why you choose nichrome wire? Because you want the high resistance to produce more heat. Okay, high resistance is enough. Enough to support your. This is a very good reason to support your choice. And then for the second one also, you want a smaller diameter of wire or thin wire. Why? Because you can make it a sentence, but using a chart like this is much easier. Yes, it's true. But
totally agree.
Yes, we are agree. But for us, if you write this, you don't need to make it then, so, hence, minimize the grammar mistake for me lah. Okay. Then what is the point for this smaller diameter? Also, we need to get a high resistance to produce more heat. Then you see these two reasons are the same, but it contribute you 2 points. Because this point is support this aspect, and another point, this reason is support different aspect. Both are accepted. Okay, then what is the reason you want to use a high power of fan? Also, you need to blow more hot air. Because in short time, you can get more energy out. That is a power. Then why you want to use a 5 fuse? You can say for safety reason, or you prove your calculation. It's 4.85, just now we calculate it. This is more the closer, more suitable. So 1, 2, 3, 4. You go 1, 2, 3, 4, 5, 6, 7, 8 marks.
8. Yeah.
Where's another 2 marks? You haven't make your choice. Okay, this choice is our T. Then you choose T, 1 marks, and then you conclude all this, write it again. Okay, to support your choose your choice, then you get another the marks number 10. Can I?
So 10 marks in the hand.
Yes.
I won the 10 marks.
Then you score A plus.
Yes.
Yes. Next, we go for the next question. This is the last question. We in section C, 2007, question number 10 also cost you to 20 marks. Okay, then we check for this diagram. 3.1 show you the circuit. We compare these two. Also, you can check for the ammeter also got reading. Show you the reading. One is higher, one is smaller reading. And this is connected in parallel with 2 metal rod. This is in 3 metal rod. Okay, the dry cell also the same.
2 dry
same number
cells.
of dry cell. Okay, then what is the question ask you? Go and check. What is meaning of resistance? Okay, what is meaning of resistance? If you don't know, we apply for the Ohm's law. V equal to IR, and then R will equal to V divided by
I.
right? So the ratio of potential difference to the current flow through a circuit. Then you will get it. 1 mark. Then
Easy.
Next. For the second one. Okay. Compare the reading of ammeter. It's already shown to you which one is bigger, which one is smaller. 3.2 is greater reading than 3.1. So we use a mathematical form. 3.1 smaller than 3.2, or 3.2 is greater than 3.1. Get 1 marks. Easy. Just few stroke, you will get 1 marks. Okay, next. Number 2. Question asks you, compare the number of metal rod. Just compare which is get more number. So 3.1 is less than 2.2. The same answer. Are you with me? The others, no response to me. I'm so lonely here.
I think this question is too easy. For sure, our student can score this one.
Yes.
Easy, very good. That's why they don't want to type. So better for you to type lah. Support us, right? Kasih Gegau, boys and girls. We want you. Okay.
Come on, give me your response here.
Yeah,
good boy. Thank you.
Where's the good girl?
Supportive.
Always good boy. Where's the good girl? Okay, can show teacher's answer. Yeah.
Okay, C. 1. Okay, the metal rod in the diagram 3.1 is using the formula. Okay, because we use this formula because it's connected in parallel.
Yes.
So they ask you to calculate how many is 2 ohm. Give you 2 ohm. So this is 2 ohm. This is also 2 ohm. 1 over R will equal to 1 over 2 plus 1 over 2. Next, 2 over 2. So your R will equal to 1
ohm.
1 ohm. I already give you answer. Yeah, Johan Lee, thank you.
Good supporter, Johan.
Okay, next we go for the next one. Okay, check again. This is 3, so it give you another formula. We just calculate as usual. 1 over 2 plus 1 over 2 plus 1 over 2. Calculate 3 over 2. Don't forget to upside down it. And you will only get the true answer. So your R will equal to, you cannot make it in fraction form, but you have to convert in decimal form. And better in 4 decimal places with the correct unit. Okay, Amma Sukri, thank you. 1 ohm. 1 ohm for the previous, right? Okay, already done. Okay, good boy, thank you again. Okay, next one, we go for this D. Okay, checking. We are preparing for D. I'll let you the chance to answer it. Okay, compare the effective resistance for both diagrams. Okay, just now we show you. We got 2. One we calculate 1 ohm, another one we calculate 0.667 ohm. So, can you go do some comparison? Who get the?
Come on, boys and girls. Come on, comparison. Yeah.
What is your answer supposed to be?
Compare the effective index.
Waiting. Come, good boy, come. Ahmad Sukri and Johan Lee, right? I'm still waiting.
Yeah.
Min Zun.
Yeah, Johan Lee, the first person give the
Yeah, the first one,
answer.
Johan Lee. Thank you very much. Okay, 3.1 have the greater effective resistance if compared to 3.2. Okay, we check the answer.
Yes.
Someone else? Yeah, 3 even. I'm not sure your answer. You got smaller, you got bigger. Good boy. Okay, let me check the answer. Thank you. I think you can. Okay, then our answer is 3.1 is, yeah, even. Thank you. It's greater reading from 3.2. Then we got state the relationship between the number of meter rod and the effective resistance. When we get more, we can give more meter rod, our R will get
Reducing
or decrease, smaller value. So what is the relationship? Okay, maybe you can answer in long sentence if you like. So when the number of meter rod is increased, the effective resistance will decreasing. Okay, the higher number of meter rod, the lower effective resistance. Yes, Yong Kian Hong, very good answer. As the number of meter rod increase, the effective resistance decrease. Very good answer. Then we
Well
go
done.
and check. Then E. For this one, it asks you, draw the pattern of electric field that form between two electrodes. Okay, we check for two electrodes. This one negative, this one is negative, this one is positive.
Positive.
Then because this is not the complete circuit, this is not the complete circuit, it's putus here. So the current not really flow. You use the help of extra high tension voltage to make sure some potential different or positive to attract the electron, because now electrons are flowing, okay, with some gap. So we must use this extra high tension. Then we check how to draw it. Okay, we have one, this is a rod here, and there is negative, right?
Yes.
And then we got a bulb here, should be positive. Our electron flow, this is electron about negative to positive, but we are drawing the electric field. So it's from positive out and go to the negative, right?
Yes.
And then this one will go like this. Because this is more circle, we'll circle and then go parallel here. Okay, this is supposed to be the answer. And then this one will go up like this, go down like this. Okay, and then we check the answer. So you have to draw, and then we put, this is a sign Y, this is sign X. Okay, this is a best answer. Well done, Yong and Yong. We got two Yong here.
So drawing also can give us marks, right, teacher?
Yes, this got 2 marks here. Easy, right? Okay,
yes.
Next, we go for the next. Okay, why the EHT is used? Okay, why? Just now we just said. Okay, because you want to provide a large potential difference between these 2 points so that the electric charge can move. Okay, if this is a complete circuit, we just use normal dry cell, the current will flow, the electron will flow. So it's no gap here. Okay, it's no gap because so many obstacles outside. You need to use this EHT, extra high tension. Okay, next.
Yes.
Okay, next. This is the last part. Okay, suggest and explain how to improve these electric ions so that we can function effectively based on the characteristic of matter which used to heating element and the handle of the ion and electron component to control the heat and the safety. Okay, next we go check. Okay, same. We have to make a use of this table to make easy to view the answer. First thing, we want to check the heating element. The heating element here, which one do you want to use? Just now we said that nichrome and the tungsten is the best choice. If you want to get more resistance, convert more heat. So maybe we choose tungsten or nichrome. You choose either one. And then the second one, the handle of iron. Okay, handle of iron, when it get heated, you don't want to hurt our hand. We will make it not hot enough. So it will pinjam idea from the chapter 4 in your form 4. There is a any idea, anyone?
Yeah,
Heat.
boys and girls, come on.
Any
Heat,
idea for this handle?
Present by Mr. Peh, you know, that day, isn't it, Mr. Peh? That day
Heat
Siri ketiga.
insulator.
Yes.
Okay, plastic.
Plastic.
Plastic
Heat
maybe not
insulator.
suitable. Can you be a handle
Because
made by plastic?
we got many types of plastic, right, Cikgu Chia?
Yes, so maybe you go and specific it. Got Johali. High specific heat capacity. Okay, we think, is it high specific heat capacity? So when it absorb more heat, it will only increase a little bit of
temperature,
right? So yes, very good. Handle made by high specific heat capacity material. Okay, then how about the electronic component to control the heat? We learn it in electronic. Previously, the teacher teach about the electronic. Which component can control heat? Which
register that very sensitive to the heat, right?
Which one? Which electronic component can control the heat? It's very sensitive to the heat. So we can.
Johan Lee answer.
Yes,
thermostat.
Yeah, thermostat. Thank you. Okay, yes, well done. Okay, you can use thermostat. Okay, we can use thermostat. And then the last part is a electronic component control safety. What do you think by electronic component control safety? A component. It's very simple, you think. Okay, I give you one idea. Do you even check? Not fuse. Okay. Do you even notice some of the electric appliance only got 2-pin plug? Something a 3-pin plug. You know how? What is the difference between 2-pin and 3-pin? 2 pins and 3 pin. The extra pin is earth pin. Earth, what meaning by earth? Earth means our bumi. So earth is the shortest way which the current paling suka mengalir melalui dia, because they're more likely to flow that way. So for some kind of electronic component or appliance with a metal case outside, we have to add one more pin, that is earth pin. If the appliance is built out outside, is covered by plastic, then 2 pin is more than enough. This is the point. So for this one, because it's a metal, we can touch a metal here. Then we should use 3 pins plug. Okay, this is the point. And then one more, because we got 10 marks, we got add more, one more. Just now we said earth wire. Yes, very good. Okay, we can use what? Fuse. Can we use fuse? Yeah, sure. We can add one fuse here, because it consider high current to flow. So just now Yong Kian Hong, very good. Yeah, we can use fuse. We use fuse, one more fuse here. Then after we conclude what we want to choose, then we get the reason. Okay, why we want to use nichrome and tungsten or tungsten? Because you want to produce heat. You want to convert the electric energy to the heat energy. And if nichrome and tungsten, the melting point is quite high, so it not easily melt. We can use this, the high resistivity, for this nichrome and tungsten. Yes, very good. Yong Kian Hong, you're very good. From which school?
Yong Kian Hong, A+. Yong Kian Hong,
yes.
A+ already. You very
bless
good.
You will get A+ in physics.
And next, the good boy as well.
Handle made of high specific heat capacity. What it for? Because cannot get hot easily. earth wire to neutralize excess energy, right? Not really. The earth wire is for the extra current to flow to. It
Ground.
neutralize energy.
Earth wire to neutralize excess energy is not clear. Normally, we flow the extra current to the
Current.
ground.
Yes.
Okay,
So
good
you
boy.
think
Not.
that okay, next step we go for thermostat. Okay, why we use thermostat? Okay, why? Because we can control the
Temperature.
temperature. And then what happened to the 3-pin plug? Because the third pin that is earth wire is safety wire. So that if got current, more current, because current, if current want to choose to flow your side or the earth wire, it will choose the earth wire first. Okay, because there is a less resistant. Our body is more resistant than earth. Okay, when if go some safety, you want to holding something and you got electric shock, but our not in barefoot, we are wearing some slipper, and then we can got some gap here. The current cannot go through. So even the current here, but it's not a complete circuit, means the current no function. It must be a complete circuit only function. But if you're barefoot, then current can fall through your body, go to the earth, then mati lo. Again. Next, we go for the fuse or electric circuit. For the all electric circuit breaker. Okay, why? For this is for our safety device. Ouch. So the earth wire to leakage energy flow to the earth.
Is to let the extra current. Excess current.
Yes, we are more to current flowing. Okay, because energy not really flow. It can is more to convert to another type of energy. Okay, then that's all for today. Because I want to let you. Okay, this is what. Okay, Puan Tiew, you continue. What happened to this code?
Okey, terima kasih kepada Cikgu Chia yang sangat comel ini tak belajar elektrik dengan Chia tak boleh tau. So demikianlah penyampaian yang sangat membantu untuk tajuk elektrik ya. Sungguh mudah analogi dan penerangan dari Cikgu Chia itu tadi. Anak-anak murid semua, kita ada link quiz di ruang message. Murid-murid juga boleh scan QR code yang diberi di paparan skrin sekarang ini. Soalannya adalah berkaitan dengan tajuk yang kita bincang pada malam tadi. Malam ini murid-murid akan mendapat sijil serta markah yang diperolehi di dalam kuis tersebut melalui email masing-masing. Masukkan adres yang betul dan nanti akan dapat paparan markah. So tajuk seterusnya gelombang, wave yang akan bersiaran pada minggu hadapan bersama seorang lagi otai fizik iaitu Cikgu Siti Zubaidah. So terima kasih kita ucapkan kepada Cikgu Chia dan Cikgu Peh yang telah memberikan sumbangan masa dan tenaga berkongsi ilmu dengan kita hari ini. Terima kasih juga kepada Cikgu Saripah binti Ahmad setia bersama kita malam ini, tulang belakang kepada program kita serta tim SISC Plus Melaka Tengah, Cikgu Salina binti Ahmad dan Cikgu Aziza binti Ahmad untuk program Gegau SPM 2021. Terima kasih kepada anak-anak murid yang kekal bersiaran dengan kami pada malam ini. Yang kekal bersama dengan kita malam ini semua dapat A+. Percayalah Cikgu Tew. So, terima kasih ya. So, saya bagi pihak rakan-rakan di sini memohon maaf atas segala kekurangan sepanjang siaran berlangsung. Semoga anak-anak menduduki SPM 2021 mendapat keputusan yang cemerlang dalam fizik ya. Kita pun telah berada di akhir siaran sebagai penutup tirai. Kali ini Cikgu Tew tak berpantun. Cikgu Tew nak bagi kata-kata yang menaikkan semangat anak-anak. So please listen here. Nothing in life is to be fair. It is only to be understood. Now it is a time to understand more so that we may fear less. So I hope you can have an excellent result in your SPM next year, right? So semoga kita bersuara lagi di slot yang ke-9 pada minggu hadapan. Hashtag kasih Gegau, SPM ku, hashtag pasti boleh, hashtag Melaka Fizik nombor 1. Itu saja untuk malam ini. Bye. Terima kasih.